Yeah, thank you, Mutas. Stuck out. Okay, welcome everybody. Today I'm going to show you the tips and tricks with SolidWorks sheet metal. Okay, so what we are going to see in today's webinar. Uh, I'm going to focus more on the features, the tools of SolidWorks with SolidWorks sheet metal. So we are going to understand some of the parameters from SolidWorks required to design sheet metal. Then we will create a simple, I will create a simple sheet metal part by using most of the familiar features with the SolidWorks sheet metal. And then I will give you some helpful tips and tricks with the use of sheet metal. Then we will see an approach to with the multibody concept. So we will see how we can approach design with a simple multibody concept and how we can produce a drawing. And also most of the users have 2D drawings, 2D legacy data. We will see how we can change 2D legacy data into SolidWorks sheet metal drawings. Okay. Before I could finish or before I could start, I want to get your opinion. What is the expertise of your sheet metal with your sheet metal design with SolidWorks? Are you a beginner or an advanced, or you do not use sheet metal at all? So could you answer this poll? Okay. Yes, great. Yeah, I can see around 59, 60% of the audience are beginners. Okay. So the concept of sheet metal. So sheet metal, it's a very simple concept. So everything starts with a flat pattern. And usually what we have with sheet metal is we have a flat sheet, a cut sheet, and then we have some reliefs in the corners. So we use some we use some press tools. So it's a kind of a forming operation. We use some press tools. And with these press tools, we start creating operations from the first bend, second bend, third bend, and then we plan these bends and we complete our sheet metal part. So this is a simple concept of how sheet metal is done. So from a flat sheet, we create the bends. Okay. One thing here to remember is the sheet. So we have something called as the bending allowance. So I'm not going to talk much about this. So actually, usually we have the bending allowance, so we have bend deductions, and we have the K factor. So as we bend the sheet, the neutral axis is not going to be at the center, exactly at the center. So based on the hardness of the sheet, based on the composition, the chemical composition of the sheet, the physical properties of the sheet, the neutral axis usually changes. And also it's based on thickness. So based on the hardness, there is a shift in the neutral axis, and the bend allowance is a calculation, or it is a constant which is used to consider it in the when you do the flat pattern. So when I do a flat pattern, I can take this constant into consideration. So with SolidWorks, what we have here is we have Excel files into SolidWorks which are having the bend files, and this has we have bend allowances. So we have 2 units here. We have the inches and we have the units. So we have the Excel file for bend allowances, bend direction, and also the K factor. So you have a constant K factor. So here you see some Excel files. So you have the K factor here, a constant K factor. You see various gauges. and you also have various radiuses applied to. So this kind of parameter can be taken based on your manufacturing need. So what is actually your manufacturing needs? So based on that, you can set these Excel files. Okay, so every sheet metal design starts with a base flange. So what we see here is I have a first base flange. So what you see here, the completed one, is actually a base flange. So on the base flange, you can start creating edge flanges. So we see here different kinds of base flanges. So after you create, so all these flanges, these edge flanges are based on a base flange. So we have the linear edge. So what kind of edge flange we have here? We have the linear edge. We can have a miter. You can have a single curved edge. So multiple tangent edges, cylindrical edges. So one thing, three main parameters here to consider with sheet metal is we have the thickness. So you have to always define your thickness. Yes, the direction of the material is also required. And then you have to define your bend radius and your K factor. Okay, so three main parameters we have to consider while we do our sheet metal design. So here we have different options. So I call this the design options. So when you create a flange from the base flange, you have different options where you have your virtual shop. So with respect to your virtual shops, you have the options where you could set your flange positions. So here one thing to consider is how do you want your flange positions to be created. So I have described here various flange positions which SolidWorks has, and with respect to the virtual shop. So this is actually a dimension of 15. So my dimension, what I'm going to enter here is 15. I want a length of 15. So it considers it from the virtual shop, the flange which it is creating. Okay, so some other design options here we have. So we have the edge treatments. So usually for doing a sheet metal bend, for doing a fold, we have to have particular edge treatments. So we have the tear, we have the rectangular, circular, oblong, and then we have the constant width. So parameters related to manufacturing is available with SolidWorks sheet metal. And whenever you do a flange, you have the position of the flanges where you can place the material inside, outside, and from the virtual shafts. And some of the other options, what we have here is we have the M's. So you have different styles of M's. So we have the closed hem, the open loop, open hem, teardrop, and the rolled hem. So for the flat pattern, so when you have a flat pattern, sometimes we'll need to give a relief which is a corner treatment for the relief actually, which can be circular, square, or a bend based. So I will not be getting into much of detail with this. So these are the options what we have with sheet metal. And before I proceed, I would like to understand one thing is, do you do high precision sheet metal components? Or is your sheet metal component just an open tolerance and it is not a high precision component? Can you select or can you choose from this? Yeah. Okay. Okay. You have your formulas. We have a formula to calculate the K factor, which I can give you this offline, but not online. I can tell you how to do the bend deduction, bend allowance, and the K factor offline. So you can get in touch with me. Okay, so there is a simple sheet metal part. So what I'm going to do is the main objective of this webinar is going to create. I'm going to create this sheet metal component. So with this, I'm going to apply a lot of features from SolidWorks sheet metal. And I believe you might get some few tips in this, which will help you in your sheet metal designs. So here I have my profile, my sheet metal profile. So as you can see, it is just a simple sketch, a sketch of around 250 mm by 100 mm. So like I told you before, we start from a base flange. So I have the base flange option here. So I select the base flange and I pick my profile. So what are the other options we have with sheet metal here? So in this case, what I'm going to do here is, let me select, this is going to be from the mid plane. And I'm going to give a distance of around 150 mm. So the length of the flange is going to be around 150 mm. Now in this case, I'm going to use a gauge table. So let me use a steel gauge table. So I had shown you the Excel files, previous Excel files. So I will choose a gauge of around 18 gauge. And you see it reads the data from the Excel file. And here I have a thickness of around 1.2 mm. And I'm going to take the minimum radius from the, this is also listed from the Excel file. Okay, I'll select the minimum bend radius, and then I have my auto relief options. So my auto relief options, so what kind of relief I want at the corners when I start a bend. So I have rectangular, tear, and oblong. Okay, and the K factor has been read from the Excel file. So having done this, what I'm going to do is I have to check the position of my material. So based on the sketch, I have the option to reverse the position of my material. So I want my material inside. So I'm going to say OK. And what SolidWorks does is it creates my sheet metal. So this is a base flange. So what I have here is a base flange. OK, just let me, to change the look, OK, let me apply the material here. OK, so I have, now once you start with the base flange, to complete my model, I'm going to go to the edge flange. I'm going to create some edge flanges here. So as you can see here, I can start picking edges and I can start creating flanges, my edge flange, and they automatically miter themselves. See, you can see here, the miter is automatically applied to my edge flanges. So here I'm going to give a distance of around, say around 25 mm. Okay, and in this case, I'm going to check my position of the material. So here I need the material inside. So it falls within the 150 mm length, the extrusion length. Okay, so having this, I have an option here. So you have different options. So where you want to place your material. So how you want to position your material. And then I have an option here where I can trim side bends. So I will show you this option. So I will uncheck this trim side bends. And then what I'm going to do is I'm going to say, OK. So here the edge flange has been created. So you can see this extension of the material here. So to remove this material, I'm going to apply this option to trim side bends. So let me go down and let me check this. And also control the gap of this distance. So between flanges, between the miter flanges, I have the option where I can control the gap between the miter flanges. So you can have a control over the gaps. So in this case, I'm going to maintain this to 1 mm. Okay. So adding additional features onto this. So let me add a tab in this case. So what I'm going to do here is I'm going to create a profile on the midpoint of this line. So let me say this is going to be around 15 mm. So let me add a base flange. And automatically, SolidWorks merges the result with the existing edge flange. So I've created a base flange. All right. I can add additional features to this. So let me say I want to add a cut here. So I'm going to add a cut of around 5 mm. And here I have the option to extrude this profile. So here, the option here is I'm going to select the link to thickness. So I'll use the link to thickness. So whatever the sheet metal thickness is there, it will cut through that distance. Okay. So having done this, let me add some additional features to the flange. So I have another option here where I can create edge flanges. So I will use an edge flange. But now in this case, what I'm going to do is I'm going to edit the flange profile. I'm going to edit the flange profile. And here you can see that usually in SolidWorks, what we understand is dark lines are usually fully defined. But with sheet metal, when you try to edit the flange profile, this is actually free to move. So you can see here, I can drag the corners and I can shape my flange, my edge flange, to the shape I require. So in this case, I want it to be a circular piece here. Okay, so let me trim this part. Okay, and then let me go back and check the position of my flange. So always remember to check the position of your flange. So you have different options to design. So where you have options. So in this case, I'm going to keep it on the inside. And also you see SolidWorks has applied my sheet metal here, the sheet metal edge flange. And you can see here it is applied the corner treatments. Okay. On this, okay, let me add a hole to this. So with this, I have the hole wizard. So from the hole wizard, I will create a hole in this on this part. So select this flange, and then I pick the center of the hole. And in this case, I'm going to have a countersink hole. So let me have a standard of ISO. Okay. Okay. IS. And in this case, I'm going to apply a hole of around M3. So a countersink hole of for M3. So having created this feature, I can apply copying patterns. So I have the linear pattern. So here I'm going to apply the linear pattern for copying this feature. And then I have the features to be selected. So you can select it from the tree. So in this case, I'm going to select the edge flange and the countersink hole. And then I can give a distance of around, say, around 100. And you see the same feature of sheet metal, which is with the reliefs and with the edge flange, is being applied with the linear pattern applied with my modeling. So I have another option here where I can, to check the flat display, I can say toggle flat display, and you see SolidWorks gives me a neat preview of my flattened pattern, of my flat pattern. So having created this, what I do next is I can also mirror this. So let me use the mirror option. So in this case, I'm going to select the right plane, and features to mirror, I'm going to use the option from the tree. And you see here, when I select and I mirror the features, you can see SolidWorks has very neatly created my edge flange with all the reliefs. Okay. So all features related to copying patterns, mirroring, linear patterns will work fine with sheet metal. Okay, so I have another option here, which is called the miter flange. So I select the miter flange, and in this case, what I'm going to do is I pick an edge on the sheet metal part. So a miter flange is nothing but you can have a flange which runs through an edge of a different shape, of a desired shape you require. So in this case, I'm going to add my miter flange here. And let me add some dimensions to this. And I'm going to say that this is going to be around 45 degrees. Okay. I will say this is going to be around 10. and give a dimension to this of around 10. And you see here the miter flange has been applied to the edge I selected. Okay, make sure you check the position of your flanges. And also, I have an option here where I can propagate my flange. So I have the option here where I can select this and say propagate the flange throughout the edge. So it selects the whole chain of the edge. And here I have the option where I can control the gaps. So in this case, I want a gap of around 1 mm. So I can control even the gaps here. And you also have the option where you can select the start and end offset of the flange. So as I click on this, you can see the start and end option, the positions vary. So I can also have a control over where the distance needed to offset from the start and the end position of my flange. So you can see here, I have applied a neat miter flange to my design. Okay, let me go ahead and add a cut to this to finish my design. So I select this face, and then what I'm going to do is, so let me first draw a profile for creating my cut. So let me add some measurement to this, and I'm going to say that this is going to be around 30 mm. And from this bend line to this, I'm going to say from the corner to this and this, I'm going to say this is going to be around 4 mm. Okay. So we have the extrude cut. So I'm applying the extrude cut to this, and I'm going to cut through a distance of around 5 mm. So I uncheck the option link to thickness, and here I'm going to say around 5 mm. So you see it gets inside the flange. So here what you see here is SolidWorks does a neat cut like a sheet metal component. So you have a neat cut here based on the sheet metal component profile. Right. Now adding additional features. So I want to add some vents to this. Now in this case, what I've done is I have my design library. In my design library, I have created some sketches. So when you have a requirement of when you want to automate certain or you have some standard profiles or standard sketches, you can use them in your sheet metal patterns in your designs by adding them as a library feature in the library. Design library of SolidWorks. So here I'm going to create a sketch, and to place your sheet metal feature, to place your sketch, you need a point. So I roughly create a point here. I'm not going to add a lot of dimensions to save time. And so once I have done this, I can drag my my profile from the library and place it onto the plane here. So once I drag my profile, you can see I've created a profile which I can drag from the library. So this is a standard profile which can be dragged from the library, and SolidWorks asks me for a point. So I pick my point here, and it positions the sketch to that point. So very quickly you can have sketches with a lot of equations. You can give equations to sketches. And once placed my sketch, I have the option where I can create a vent. So here there's an option with sheet metal where you can design your vents. So in this case, I'm going to say this is the outer boundary, and then I have my ribs. So as I move on, I have my ribs. So I'm going to say that the vertical and the horizontal ribs are going to be of thickness around 3 mm. Okay, and this I'm going to use this as spars. So these are the additional, these are the spars which are connecting the ribs. So I can have this at around 2 mm, and this inner portion is going to be my fill boundary. Okay. So additional options you want to, I want to add a slot for a USB. So the similar thing I'm going to do here, I'm going to create a point, drag and drop my profile from the library. And here I fix it on my sketch point. And you see I get a profile, a neat profile. a standard profile from the library, which can make my work more faster. So now I can apply my extrude cut and create my cut here. So you can make use of your standard library, SolidWorks standard library, where you can save your standards, your sketches, and you can use them from the design library, which is a very big time saver. So on the top plane, in case most of the sheet metal parts sometimes need to create, you have to create vents. So in this case, I'm going to create a vent to this. So the vents are nothing but just a hole for ventilation. So let me say this is around 50 mm. And we have an option here which is called the fill pattern. So we have the fill pattern. So I can select the fill pattern and I pick my sketch, and here, okay, let me pick a direction for the sketch, and let me create a seed cut. So SolidWorks has some primitive, some defined shapes where you can select these shapes and apply them on your components. So I can create a seed cut, and you see it's very quick. So fill pattern is one of the options where you can use to create your vent holes, so drain holes, filter holes. So this is a very good option where you can use with SolidWorks, right? And also we have the form tools. So form tools are tools which are actually tools which create an embossing kind of operation. So here I have a form tool. So in this case, I'm going to place a louver. So I can rotate my form tool. I can flip it also. So I have the option to flip. I have the option to rotate it. So let me rotate it. And you can see here, you can add form tools into the library and place it very quickly into your sheet metal designs. Applying of linear patterns to this form tool is also possible. So I have my direction here, and then I select my features. So let me select my feature, which is the form tool. And okay, let me increase the count. Sorry. Okay. So you can see, you can start placing form tool features into your sheet metal component. And here you can see I've had a very good sheet metal design complete by using simple features from SolidWorks. Right. So I have the option here, like I told you, you can also use the option to toggle flat pattern display. So you can see here, it gives you a preview of your flat pattern display. Right. So we have another option here is where you can go and create your flat pattern. So I can say I can create my flat pattern. So in the flat pattern, yes, there are certain things which I do not want in the flat pattern. For example, this countersunk is going to be done after the completing the operation of the folding. So after that, they're going to do this operation in the shop floor. So I do not require this phase, right? That's one thing. Okay, so in this, what I have is I have some additional options here with flat pattern where I can edit features. And here I have some options where I can merge faces. So you can merge the faces when you flatten the face. So when I flatten it, you can see here I have the bend lines, and you have the outer line and the inner line of the bend, the start and end of the bend, and you have your bend lines. So if you want to merge these faces, you can use the option here to merge these faces. So if you check this, it will merge these faces. So you can see these faces have been merged. Okay. So here I have one option here, which I want to exclude. So I have the grain direction. So I can select my grain direction for the material. And then I have an option here, faces to exclude, and I can select this option. So I'm going to select here whatever faces I want to exclude. So just pick your faces you want to exclude, and this will not be included in the flat pattern. So these faces are excluded. Okay. To save it as a DXF, I can right click this and I can say export to a DXF file, and then you can select your, you can save it as a DXF file and select the option here for sheet metal. And what are the options required in your DXF? You can produce them. So the alignment required. So what kind of alignment you require, and into what file you want, into single file, or if you want it into separate files. If you have multiple sheet metal flattens or multi-bodies, then you can put them into separate files. Okay, so what we saw here is we saw something with a simple creating a simple sheet metal part. Okay, so very simple concepts with sheet metal. So always remember you have the option where you can use the design library, and also with the flat pattern you have an option here where you can one minute, let me come back, and here you have an option with the corners. So you have the corner trim here with the sheet metal. So in this case, when I say collect all corners, you can see here it collects the corners. Sometimes you might have to give some reliefs. So you have different types of reliefs here, relief types in the sheet metal flat pattern. So you have the circular relief, the square relief, and the bend waist. So if you want to center this to the center line, to the bend line, yeah, this is possible. And the shape of your, the size of your shape can also be defined here. So before manufacturing your component on the flat pattern, you have the option to provide reliefs from the flat pattern also. Okay, so these are some of the options which I was explaining to you about the flat pattern. We have an option here which is called the part reviewer. So some of the tips, I just want to give you some tips which I felt was useful while working with the sheet metal. So you have the part reviewer. For example, if I have to demonstrate the part reviewer to you, we have a flattened part here. So if I want to know how this part has been built, so you have the evaluate tab with SolidWorks, and then you have a part reviewer. So this is the part reviewer. So I can go to the part reviewer, and what I can do here is I can start playing this. So I can say I want to see this step by step, how this component has been created step by step. So I have, when I say the next step, so you can see it starts with a base flange, and then the edge flange. It also gives you the, it shows you the dimension. And what this does is usually most of the users, what we do is we have the rollback bar. So we use the rollback bar and we move step by step. But this is a kind of more advanced kind of display, so which can also display the dimension and the sketch. So you can see it shows me step by step of how the part has been created. So this is a good option, which is called the part reviewer, which you can utilize in your daily work. And then also we have a selection tool, which is the magnifying selection tool, where you have sometimes you have to zoom in and you have to select. So you can have use the G tool. So in this case, if I use the G tool, you can see here it magnifies. So I can magnify. So sometimes I want to pick certain edges. I can just zoom into this, use the G tool, get in, and you can see it gives a good magnification here. So this is one advantage while doing selections with SolidWorks. And then we have the interference detection, which I will be showing you in the further slides, and the split body I will be showing you in the further slides. I have shown you the flat pattern toggling display, where you can check if your flat pattern is possible or not. Okay, you can see a preview of your flat pattern. And I've also shown you the fill pattern. Okay. Now I have, from the design point of view, I just wanted to show you there's a multi-body with the multi-body concept. For example, I have a toolbox. This is a toolbox here. So how do I create with using multi-body concepts? So this is a challenge for most of the designers. So how do I start creating a toolbox? So how do I start with the first flange, base flange? How do I start with the edge flange? And what are the features I'm going to add to this? So I've just created a very simple concept with SolidWorks. I hope this concept will help you to build upon. Okay, so here what I have is, okay, let's use the part reviewer here. So in this case, what I have is I have created a body. So it's a very simple profile, and with a size of around 2 meters, 0.5 width and 0.5 height. Okay. And if you see here, I've added some split lines to it. So what I've done here is based on the sketch here. So I have some edges here. So based on this, I have created some split lines here. So we have an option with SolidWorks where you can also create using the multibody concept. So in this case, what I'm going to do here is I go to sheet metal and I'm going to convert this to a sheet metal part. So this is a solid body. So you can see here it displays a solid body. So I say convert to sheet metal. And in this case, what I'm going to do is I'm going to select my my details from the bin table. Okay. So here I'm going to select. So let me select steel here, steel units. So SolidWorks collects all the data from the Excel file, which is your bend factor, your gauge thickness, and your radius. So here I'm going to apply the, let me say I'm going to take 16 gauge. Okay, 16 gauge is around 1.5. Yes, and the minimum radius is around 1.9. So in case if you want to change the radius, you have the option where you can override the radius. So having selected this, now I go ahead and I convert this solid body part into a sheet metal part. So the first thing here is I select a fixed entity. So this is my base. So this is the fixed entity. Now the second option here is what I'm going to do is I'm going to say how I'm going to form this. So how this is going to be bent. So I'm going to select that, okay, this is going to be the first bend. Okay, I can pick edges and I'm just moving by folding the part around its circumference, around its outer face. So I can say yes. So I've got a bend here, which is the base face here, the left and right, and the top bend. So here I can add another bend by selecting this, and I can say, okay, bend at this point. So you can see SolidWorks clearly understands what are the bend areas, so bend radiuses, and then it understands where it has to split. So where is the rip also? So it understands the rip. So let me go ahead and select this line and this line. So I get a very neat fold out of my solid body. So let me check if the material is inside or outside, because I want this material to be within the solid body. So you can see here, when I reverse the thickness, the material comes outside, and again it is in. So when I uncheck it, it is in. So let me say OK, and you can see here SolidWorks very neatly creates a sheet metal part for me. So I have an option here where I can say toggle flat display, and you can see I have a sheet metal part created from this solid body. Okay, let me add another component onto this, which is a simple bracket where I want to support my toolbox. So I'm going to add a plane. So let me create a plane of around 300 mm from the face. Sketch on this. And then I'm going to convert edges. So let me convert my entities. So I'm using the existing edges. So in this case, I'm going to create another sheet metal body, which is called a bracket. And then we are going to see how it works with the within assembly. So how multi-bodies function with sheet metal. Okay, let me add a dimension to this. So let me say this is going to be around 150. Okay, so just a simple line. So let me join the corners. So I believe with the trim concept, you have used this corner option. So you have the corner option where you can select this and you see it joins the corners. So then using, taking time and dragging and merging the corners, you can use this option to drag it, to select the entities and create the corners. Okay, so here, let me go to sheet metal, select a base flange, and I'm going to pick this sketch. And in this case, I am going to use the gauge table, but I'm going to use a different gauge. So in this case, I'm going to have I'm going to reduce my gauge. So let me take a 12 gauge. So you can see I'm using two different gauges in this modeling. Okay, so let me say this is going to be around 75 with respect to the midplane, with respect to the sketch. Now, like I told you, you have to check the position of your flange. So how is my flange being placed? So in this case, I have I reverse the direction, so it doesn't merge with the existing body, right? And let me say, okay, so you see I have created a sheet metal body. So you can see here I have two components of sheet metal here. Right. So let me go on to complete my design of this bracket. So let me add a line to this. So in this case, I want to have a jog so that this will shift only by the thickness. So I press this or I form this only by the thickness where we have the jog tool. So I select the jog, I select my fixed face, and then what I do is I am going to let me reverse this, and you see here I have different options for using the jog. So I can have the fixed length. So here I had a distance of 150 mm. So if I uncheck this, SolidWorks automatically shortens the length. So it does the calculation by itself. So I can use a jog, and here I have the option where I can give the distance for the jog. So different positions, I can give the distance for the jog, and here I've created my sheet metal bracket. Okay, so usually after doing this, the thing is I first check my interference. So you can also check your interference between parts in the parts. So this was, I think, if I'm right, this was implemented from 2019, SolidWorks 2019 onwards. You can also check interferences in parts. So I just do this, I calculate it, and you see I do not have any interference. So always while designing a sheet metal component, you have to make sure your sheet metal components, your sheet metal assemblies are free from interferences for manufacturing. Okay, so having done this, let me add some holes to this. So let me select the position of the holes. So I need some holes to mount this. Okay, so let me say I want this as M8. So let me position it so that they maintain the design intent. Okay, so I've created my holes on this bracket. So some mounting holes. Now I can apply the mirror option. So I can say mirror this option, and before that I want to remove the corners. So usually sheet metal parts should be free of sharp edges, so it doesn't hurt. So I have the option here where I can select the faces. So SolidWorks understands the edges, the sharp edges, and in these sharp edges I can apply the chamfer or I can apply a fillet. And you can define the size of your fillet or chamfer, and you can see SolidWorks creates the feature for me. Okay, so I can also apply the mirror option. So I have the option where I can mirror this. So in this case, I'm going to select the right plane, and here the option to mirror it is bodies to mirror. So in this case, I'm going to select the bodies to mirror, and you can see SolidWorks creates the component on the left-hand side. So what if I right click and say toggle flat display? So you can see here, I can check the flat display of this body. So toggle flat display. So you can check the preview of your flatten pattern with your toggle flat display. Okay, so let me go to properties here and let me add some options with the cut list. So here I have my cut list. So I have the sheet here. So in this case, I'm going to say this is the main sheet. So what I have here, okay, I'm going to select this and I'm going to change the description. So this will help me while I'm producing my drawing. So I'm going to say this is a bracket. Right. Okay. So let me save this and let me go and create some drawings for this. So let me say I make a drawing for this. And in this drawing, what I want to show you here is I want to show you how we place multi-bodies into drawings with the flat pattern. So in this case, I'm going, my area of concern is the flat pattern. Okay, so I have the option here. So let me select the isometric view. First place my isometric view. Let me convert this to a shaded part. And then I have the view layout. And here you have the option where you can have a model view. So I'm going to select the model view. And then I'm going to say here, I'm going to select it from a body. So this is the main body which I'm going to select. And in this, what I want to include is I want to include the flat pattern. So I select the flat pattern. And you can see here, I can place my flat pattern. So SolidWorks places the flat pattern of the main body. Okay, let me place the other view of the bracket. So I have select bodies. I can pick the bracket, say OK. And then I move on to the, okay, 1 minute, I missed it out somewhere. Okay, so I'll say model view, go back, select bodies, and then I have my bracket. I will say I need to place a flat pattern. And you see SolidWorks right neatly places a flat pattern for me. And as usual, you also need to generate the cut list for this. So I have the cut list here where you can select the cut list. Okay, tables. So here in this case, I'm selecting the weldment cut list. I pick my multi-bodies, and you see here I get a neat cut list of my parts, a beautiful cut list. Right. So adding some balloons to this is also important. So here I will need to add some balloons. So I can go here to the annotation. I can say here I need to auto balloon this view. And you can see here SolidWorks has placed a balloon. So 1 and 2. So let me say auto balloon and pick these views. And you can see here. So I did an auto balloon here. So when usually you do multi-body concepts, you can see here the balloon name is, number is 1. So it refers to 1, and this is also 1. So in this case, what I'm going to do is I'm going to go to the view and go to the properties of the view and link this property to the weldment cut list. So when I select the properties, what I have here is I have this option where I can link the balloon text to a specified table which has been placed here. So you can see here, now this has been updated. So the similar thing here, I go here to properties and check, make sure you check this option. Okay, so the advantage of doing this concept. So what is the advantage of doing a concept like this? So when I have a primitive or I have a base feature, it is very easy for me anytime if I want to update my dimensions, I can update them. So when I update them, automatically my sheet sizes will update. So suppose, for example, I'm going to say that this is going to be 300. And once I rebuild, there might be some errors might come in because you might have to recheck the geometry. So make sure you give proper design intents and make sure you match you coincide your sketches properly. So you see here, I can quickly create parts, modify my designs to any shape I want. And in case you want, if suppose the sheet metal component is too lengthier, so I want to split it. So you have the option also where you can use the split option to create separate bodies. So here I can use the split option. I use the trim tool as my plane, as my right plane, and here I can say cut bodies. So when I cut the bodies, you can see here, I can have the option for cutting these 2 bodies. And you can see here, SolidWorks creates 2 more bodies of a sheet metal part. So what we saw here is the advantage of doing a multi-body concept is when you have a concept to design, you have to start from scratch. This concept will help you a lot as well as when you try to change parameters. The associativity between the sheet metal features and the solid body is a feasible option. Is a very good option for design. Okay, so with this I complete my multi-body concept. And some of our customers have legacy data. So some customers ask us, yes, we have some profiles, we already have some drawings in AutoCAD, and how do we, in 2D CAD, and then how do we have to take it to SolidWorks? So I have a simple example here for you. So in this case, I have a drawing. So here I have a 2D drawing. So make sure you have a single 2D drawing. So first things first is what you have to do is make sure you match this profile to the origin of your 2D drawing. So I've merged this to the origin of the 2D drawing. So this becomes the 0,0 point. Okay. So a simple way to get this into SolidWorks is let me move to SolidWorks. So I start with a new drawing. So let me say a new part. Okay, so I'm starting it from the top plane. So if you see here, this component looks something like this. Okay, I have a 45-degree cut here. And if you see that with the top and the front face, it is going to be around 90 degrees. And this is 45. And also, yes, obviously, this is 45. Okay, so what I do here is I start with the top plane. I move to my CAD, select your profile. So in this case, I will just do a Control-C, the easiest way to take your profile and paste it into SolidWorks. So when you have a sketch, active sketch, you can paste your 2D profiles into SolidWorks. So having placed this, you have an option to actually, let me select this, and you can see my origin was 0,0. So this has to be fully defined. So you have to start adding dimensions to make this a fully defined one. So you can, I will not be explaining this on fully defined sketch. You have an option where you can use the fully defined sketch, which will actually create geometric relations and dimensions to make your sketch fully constrained. Okay. So once they have taken your 2D sketch into SolidWorks, you can start with the simple base flange. So in this case, I'm starting with the base flange. And make sure you clean your 2D sketches so that you do not have overlapping lines. So with respect to the sketch, always make sure you try to check if it is how is the position of your material created. So you can use the gauge tables. So I'm not going to use any gauge tables here. So you can use your gauge tables like how I demonstrated before. And okay, in this case, it's going to be around 2. Okay, let me say this is going to be around 3 mm thick sheet metal, and then I have the option for the K factor. Right. Okay. So let me say okay. So I have a base flange created here, and here let me show the sketch, and I'm going to create bend lines. So I'm going to convert the existing bend lines. And here I'm going to use a sketch bend. So I'll use a sketch bend. So let me select my sketch and let me say this is the fixed face. And I'm going to say that this is going to bend downwards, around 90 degrees. And you see here, you have always go through your design options. So you say it's bending through the center line. So I have created my bend. So let me start creating another sketch here and convert the other line. So I'll convert this line, the second bend. And then I'm going to say that, okay, this is the fixed face, and this is going to be bent at around 45 degrees, which is towards the bottom. So this is centered to the bend line. So to complete my model, let me create third bend. Okay, so let me convert this. And then let me say this is my fixed face. And in this case, I'm going to give here as 45 degrees and flip it. So from your existing 2D flat patterns, it is easy for you to create these folded patterns to convert them to SolidWorks and to make use of a 3D with your SolidWorks designs. Okay, in case you might have a question, in case, okay, my drawings are not very similar to this. Usually what we have a lot of profiles. We have the top view, we have the front view, we have the side view, we have a detailed view. So in that case, you can choose profiles. You can choose profiles off scope to apply a particular feature, sheet metal feature, and take them to SolidWorks on the respective planes, and you can convert them to a sheet metal part. Okay, so with this, I have finished my demonstration. I hope so. I have completed my demonstration. See, I think here when I flatten this, I think you can see how the position is here. So the position changes. So in this case, let me go here and let me say that this is going to be, so I go to my flat pattern. So I want to show you another tip here. I go to my flat pattern. So I say flatten. I have my flat pattern feature inside the flat pattern folder. I edit this. And you can see here in this case, the fixed face is on this side. So you have to redefine your fixed face to the top. So once I define it to the top, you can see I get a very neat flat pattern based on my 2D sketch. Okay. What we saw here is we saw the conversion of a simple conversion of 2D legacy data from 2D CAD to the sheet metal, SolidWorks sheet metal. So just to summarize on my presentation on this webinar, what we saw is I just ran through, because my scope of interest here was to show you the features, how you can create a sheet metal part, how easy it is to be worked out with a simple parametric design, creating of a simple sheet metal part, some tips and tricks. So we saw the interference detection. You can remember the interference detection, the split body option, the fill pattern, the G tool, and the part reviewer. So these are some of the options which will help you a lot in your day-to-day work. Okay, and then we saw the approach with the multibody concept. And in this, you also always remember that you link the drawing view with your cut list, sheet metal cut list. And then we saw how we could convert a 2D data into a 3D CAD model. Okay, I've completed my demonstration. I would like to get some information from you. So what would we be looking at with your next webinar? So most of our webinars will be a kind of, it will be a kind of a training where users can gain a lot of knowledge. So these webinars will be of interest where you can gain a lot of knowledge, a lot of tips and tricks. If you have any queries, you can get back to me. Okay. Can you select this? Can you select the poll? Yeah, we can have a session on your requirement. Okay. Thank you so much. And okay, how do you want to connect with us in future? How do you want us to connect with us? How do you want to connect with us? Do you want to have more information? Okay. Are you interested to know about the pricing of, or you are interested to know about any kind of a package with SolidWorks? Would you like to have some demonstration on some specific modules? or specific solutions, or would you like to have a evaluation license, or would you like to evaluate simulations? So simulation is one of the very need in the for a designer. Because I had one of my customer asking me on this sheet metal part how much of load it will take. So that was a very good. So some of a simple questions. So this can be achieved with simulation. So we can have a session with you to show you how we can use simulation in your designs. Yes. 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 Yes, Mutas. Sure. Thank you. Thank you, Mutas. Yes, Mutas. Yes, Mutas. Thank you, Mothers. Thank you, everyone. Bye bye. See you soon. Next webinar.